Okay, is there any button I could press to make sure? Oh, it works like magic. Okay, good. Let's get back to the basics, right? So we've heard a lot about data. We've raised ourselves to the heights of all this metadata annotation, right? And now we'll go all the way back to the basics of this is not the right website. So the repository you cloned, it came from our GitHub for repronim. Everybody knows that place by now? Yes?
Your statement, the repository you cloned, didn't mean anything to me. So does that statement mean anything to everyone?
Oh, nobody cloned anything yet, huh? I'm sorry. Okay. But you all know about github.com, right? Because everybody said, or majority people said, that you're proficient with basics, right? So, and basics included Git. So who knows about Git a little bit? Come on, be brave. A little bit, I said. Okay, good. A little bit everybody knows. Everybody knows GitHub, right? That's a website. That's you enter the address, right? And then you go repronim. And we have all our training materials, not all, but majority, within the repository, which is now second in the rating there, OHBM 2018 training. Okay? Everybody there? And then rendered materials, which I'll use. So this repository contains all the sources and scripts and code, right? But there is also a website which is rendered for some materials, and it is at reproducible neuroimaging.org, OHBM 2018 training. So you could easier, I think, get there by following this link which is in description, okay? Everybody got there? Because I think it would be easier if you have your browser also open there, so you could cut and paste code sometimes. And we'll get back to computational basics. As previous speakers mentioned, we have extended set of materials. And in this time course, which I have only like an hour to talk to you, I don't have enough time to cover them in detail, but we'll go through some aspects which I think might be, although rudimentary, but they're really helpful in your practice. And first one will be shell, right? So in that questionnaire, we didn't separate out who is experienced with Git or shell. So who thinks that they are okay with that black box you find when you start a terminal? Half people, right? Even our teachers, one of them, huh? The rest were sitting and not raising even a hand. So the first topic will be about shell. But overall, what we wanted to capture in this reproducibility basics is that what reproducibility is about knowing what was executed on what data, in what environment, right? And we will try to go through some topics, even in that black box. Knowing them or being proficient with them would help you to be reproducible without actually talking about, reproducible science. It just become more efficient. If you are more efficient, if you automate more things, you become more reproducible. And let's just go through first topic, this shell thing. So what is a shell? I don't know if everybody could answer that question, but it is actually, it came from Unix environments, right, where you could enter this black box and run the commands. When I first started to use shell and I switched from Windows, which has all kinds of buttons, right, so it was much friendlier to me in Windows. I had the menu, I could click, I saw at least some materials which I could use. In shell, it was like a black box to me, right? So I have it, I don't know what to enter, I don't know what to run, and I didn't know how to get help. There were no help button, right? But actually, shell is quite friendly after you figure out what to run and how to execute to get help, right? And that's what we'll go through in this lesson. So first topic is actually seeking help. So for majority of commands, you could type the command, then space, then -- help, and get your help for that command. And that will be our really big exercise. Number one, warm up, right? So try to run some command in a shell and get a help for it. So nothing major. I started my terminal, right? What was the shortcut? Here we go, Control-Shift+ to make it bigger. So this whole lesson will be more about getting good practices and becoming more efficient. So there will be no mountain-breaking reproducibility kind of achievements. So if you are bored, also put the red sticker note and somebody will come and help you, to get something advanced. So, but hopefully you'll all find something new. Okay, what I said is to get help, right? So for any command, let's say this whole shell we are running is actually bash shell, right? So if we want to start another shell, it would be command bash, and I want to see what is the help for it, right? So I type bash-help, and I've got some summary. It wasn't really detailed, but it gave me some idea about, options, command line options of that command. And many commands might provide more or less, but majority of the help actually comes in man pages. So who is familiar with man command? Majority, that's great, okay. Who knows how to exit man command? Some people, okay. So this topic is really basic, right? It's how to navigate through this output which we get when we run man, okay? So for pretty much majority of commands in shell, you could get help. And in this case, I'll do man bash, and it opens up quite detailed description of things, which it pipes, that's a term, pipes into command less. And less you already used, I believe, in previous exercises. Less is just to view text files, right? So all shortcuts will be the same if you just less some file. And those shortcuts are listed here. So first shortcut to know is help, right? So it's again, how do we discover help within something?
So I think we used more.
You used more, you should use less. You should use less.
Just explain the difference.
Yeah, that's pretty much explained somewhere else, but more is older version of less, let's put it this way. And it's less efficient. So just remember about less. Less is more. Yeah, less is more. Less has more, just to confuse. But you don't need many shortcuts in there. And here we outline the ones which I typically use. And the most important one is to quit, is Q, right? So then I quit. And another important for me is to search. If I'm looking for something, I type / and you could see that at the bottom it changes appearance, right? So we have the search, and then I type, I don't know, I actually didn't look, but next topic somewhere will be about history. So I typed history, pressed enter, and now I could go through these places where history is mentioned. To go to the next hit, it's N. So I go through all of them, okay? So it helps you to search for stuff. Speed up, okay. Repeat. Okay. Man bash / brings you the search. You type the term you want to search for. You press enter, and you end up at the first hit. If you want to go to the next hit, you press N. If you go to the previous one, it's, I believe, P. No, I was wrong. So I don't remember how to go to the previous one. You could find it in help, which you type by H, right? But we'll not go there. So B, back. Good. Okay, so we've learned something new, even I. That's great. Okay. Now we are pretty much already doing that. Navigate man for Git. That was our next exercise, which we'll do now to the word. We'll do man Git, right? That's where we find help, detailed help for command Git. And where I mentioned somewhere else, for every command in Git, let's say we have Git. Who gives me any command of Git? Clone. Here we go. If we type help, by default it will open us a man page for git-clone command. See, here we go. We're already in man page for git clone command, so we could use the same shortcuts, go up and down, right? Search for whatever we want to search, and quit. Okay? So that's our exercise number 1. Anybody has problems? I see some pink. No pink? Okay, all yellow, good. Find commands for work with containers. Okay, so next topic is that within those man pages, we could find stuff. And man-k command gives us a way to search through short descriptions of commands. So the next exercise, which you do yourself, although you could pick preview in here, right? Find commands which are available in this dark box, which have to do with containers. That's the exercise. And how do we do it? We do man-k containers. Okay? And then it gives us a list of commands which are present, which have to do with containers. To scroll in the terminal, who knows how to? Shift page up and down.
On that man-k, does that only search the commands that you have installed? So
yes, it searches only through the man pages which are available in the system. So, and it searches only through those, and maybe some commands came without man page. So it's not guaranteed that every command has a man page, but it's typical to have one, okay? So this way you could find something for the topic of interest. Let's say neuroimaging, maybe something mentions nothing appropriate. See, there is nothing about neuroimaging yet. Neuro, and nothing there, okay. What else? Git. Here we go, at least some hits. So nothing mountain shaking, right? We just, what we've learned, how to get help, how to search through help a little bit, how to use our navigation within help, okay? Any questions? Next huge topic is actually to learn how to exit Vim. So that's kind of cornerstone. Vim is a really great editor which many people use, but it needs a little bit of learning, and most of the time people start Vim and then they don't know how to exit it even, right? Not to edit. We don't want to train you how to edit, but at least to exit Vim. So let's say if I started to edit some file, I have some file here. Yes, Dave?
what is Vim?
Vim is an editor. So like you use gedit, which was more humane kind of. You could just enter stuff and it appeared on the screen and then you saved. With Vim, it doesn't work like that. It has different modes of operation, which is really great for some, but you need to learn it, okay? In our case, we'll just learn how to exit, and that's what this page teaches you. You could exit either with saving or without saving. Without saving, it's escape, just to exit some kind of mode inside Vim, and then Shift-Z, Shift-Q, okay? Shift-C, Shift-Q, I quit, right? Just remember. Just if you end up in some editor which you don't know how to manage, it's probably Vim, and you should exit, and you do this, okay? Okay, next major topic is environment variables. Who knows about such a thing, that it exists, environment variables? Majority of people. And so, environment variables are very, very important. Some of them especially. And the most important one we go through is path. So who knows, kind of, who has intimate relationship with this variable? Good, some didn't. So path instructs you, in the shell, it tells where to find the command to run. So whenever I type git, right, where does it come from? How does it know which git to run? Okay? So to discover, and there is environment variable path, to display, I just do echo command, and then I say $variable name, and it will display it. So it's colon separated list of paths where it would look for the command to be ran. Although it's really rudimentary thing, it's probably one of the cornerstones of reproducibility, because most of the time people don't know which command actually they're running. They just run something. I used Python, right? How many Pythons do you think you have on this system? Okay, let's figure that out. So that will be our next exercise, right? First exercise, determine which program, full path to it, executed when you run git. And how do we do it? Well, there is answer, right? So there is command which you could use, which will give you the path. So which git am I using? It's user bin git. Which Python am I using? It's apparently home vagrant miniconda2 bin Python. It's not just Python from user bin.
Which are you using?
Which I am using? That's a good question. And it will say that This one is this one, although I thought it would be built-in command of the shell, but apparently there is a command user bin which. Okay?
How would a built-in command look on your which?
How built-in command? Okay, which built-in command do you know? Source. Which source? Doesn't say anything. Oh. Okay. ls. There is bin ls, I believe. Here we go. So some commands are built into the shell. So for those which will not tell you anything, but those which are from somewhere in the path, that's what you'll get. You'll get full path to it. And the next exercise is actually, where was it? Oh, it was, here we go. What about Python command, right? And try which a as well. So which Python gives us this anaconda path, right? And -a makes it output all Python commands which possibly could be found within the list of these paths which you have. So if we didn't have this home vagrant miniconda 2 bin in our environment variable path, it would have used next one, user bin path, which we would find by looking into this path. Okay? So next exercise was how to add path to where the shell looks for commands. The answer should be obvious to you now. You know how bash does it, right? How shell does it. How can you add a path for shell to look for commands? You could do that, but you don't have to if you want to do it only for this kind of, for now. You could do that, but you don't have to export. You could just set it up, right? So you could say path is equal, and then you could either prepend or post-append the new path which you want to look through for within, right? So let's say I have a directory. I'll create directory bin, and I'll create my own Python. Vim. I'll use Vim. I'm sorry. And we'll talk about. I'll just do bin bash. There will be a question about what is this thing. Who knows what is this thing? What is the name of this first line in the file which I make in a script? Huh? Who knows the name? Shebang. That's right. So remember that shebang. I don't. Why? It's probably shell and bang. Right. Oh, hash bang. Right. So we have hash sign and bang. So it became shebang. Okay, and here I'll do running Python now. And I'll do Python. So this script does nothing besides echoing some command and then running Python with all the parameters I give to this script. So it's my little scripty, and it's not yet executable. I'll make all be possible to run it. If I just type Python now, will it be executed? No, right? It wasn't the one because we have home vagrant miniconda bin2 path blah blah, right? But I could say path is equal, and then we'll see if export is needed or not. I don't know. Path is equal to home bin. That's where I've put my Python, and then previous value of path, right? So now I'm redefining path variable to point to my home, which is another environment variable. See, everything in shell kind of driven by those environment variables. Home points to my home directory, and then /bin is this new directory, and then previous value of path. Okay? So in reality, it will be this statement. So path is equal to something new, colon, and then old value. So let's run it. I'll remove this. Now if I ask which Python, it's this Python, right? And which Python with -a, it's like now it would have considered all those in this order, right? Bin Python, then that Python, and again this one. Oh, apparently it was already in the path somehow, but it was after miniconda. Now I kind of forced it to be first. Is it all more or less clear? Yes? And if we wanted to make it for sure for next time, what we could modify? Bashrc, right? So if I start a new shell, this shell doesn't know about changes to that environment variable. It was adherent to that process, right? So this path doesn't have it. If I want every bash to override this variable, I could modify bashrc file in my home directory and do this. Oh, see, it's already doing it here, but it adds it for home miniconda, right? And I could say, no, I want my bin to be ahead of things. Now, if I start a new bash or just start a new terminal, I'll make it bigger again. Okay. Now, hold on, path. And which Python? Yeah, so it's new one. So environment variables are very important. Many processes in the shell modify them one way or another so they could find new tools. Okay?
Can I just make sure that you echo yet again how important the idea is that there are 3 Pythons or more FSLs, or you can have lots of things lying around, and if you don't pay attention to your paths, you lose control of knowing exactly which command you're running. So I think that's a great example of being worried about multiple things existing and which one is being run.
Right. And pretty much what we've done now is just solution to this exercise, right? We defined path or we prepend it with new path. Another thing to be lazy but also efficient in Bash is completions. Who has heard or who uses completions? Not enough. Not enough. I know that guy uses, but he's staying silent. Okay. So completions are great. And all automation you could get out of shell, more you automate, the better. And completions is something where you start typing command or option, and then you press tab. And it gives you choices. First, it didn't give me any, but I was persistent. I pressed tab again, and it said, oh, I have 200 choices, right? Should I display them? I said, not yet. I'll type I as well, and then tab, and it gives me the choices, okay? So it allows me to get commands quicker. Sometimes it works. See, in this shell, it works even for subcommands of commands. And even it works for options, I believe. So now I could complete full commands instead of typing them all the time manually and making typos, right? I could just press tab and go through possible choices I have. Okay? It's really powerful and really handy. And the same applies to basic commands. Let's say cd is for, come on, be brave, be bold. Just speak it out. What is cd doing? cd, everybody whispers, come on, make it loud. Change directory, so change directory. And the same works there. If I type tab, it completes only to the directory. So if I have also files, it wouldn't even complete for them. It's handy, right? So it allows me to faster go through directories, user, bin. See, I'm just pressing tab. I don't even type anything, and I'm already traversing the file system. Although this one I could go forever. It's symbolically pointed to itself, right? So I could complete and complete. So completion is great. It allows you to faster compose your commands without typos, okay? Let's go to the next one. Next topic is shell history. So who knows about that it exists? Many. Okay. Who thinks that they use it the most efficient way? One guy, Germans. They figured it out. Okay. I'll kind of fast forward. What is most useful command I find is this, and I'll make it even bigger so everybody could see it. Here we go. Hold on. Control R. So who uses Control R on their daily basis? It's not that bad. Many people know, okay, but many don't. So Bash history is just a file where Bash sessions are recording which commands were executed, right, with whatever you typed. And this one, apparently, it stored all the commands, not all, there is a limit to which it stores, which commands I've ran. And you could visualize them by typing command history. But that is not as useful because you need to cut and paste, right? And then you need to press Control-Shift-C, Control-Shift-V, right? So it makes it long procedure. There is a shortcut, which is Control-R, and it goes into this reverse incremental search mode. Now I could start typing some fragment of my command which I used to run once, and it will bring it up as a choice. So let's say I saw this install command. I started typing ins, and it brought that one up. If I want next hit, I'll do Control-R again, because I want it install, not uninstall. And I'm on that command, and I could press Enter to run it, or I could press, let's say, Control-E to go to the end of the line, Control-A to the beginning to modify it a little bit, and then execute it. So this way, I could bring up from history previous commands, execute them without even retyping. And why is it so powerful? Because then you avoid typos while typing commands. So you're not only becoming more efficient, you can become more reproducible, right? Just by reusing the commands which you previously used with minimal adjustment. Let's say if I just want to install second one, I modify one letter and I'm done. If I had to retype it, it would be longer. And unfortunately, Bash doesn't store all the commands for forever, but I thought we had a section here. Right, so eternal history. You can configure your shell to store all commands which you ever ran. And I found it super useful sometimes. Whenever I used Bash, I've created a history with commands which go all the way to 2002 or something. And sometimes it's like, which command from FSL I used to do this batting on this file? And I just ran my script using that shell chronicle-like setup, and I just got those commands back. So it allowed me to figure out the details, how I did that analysis ages back, in the time of when reproducibility wasn't heard of, right? So I would advise you to kind of set up your shell so you get the most benefit from it, use completions, use history, and then we answer what JB wants.
If I have several shells,
yeah,
what is happening to the history? Is that one big file, and how that's?
So whatever setup I used, which I wrote, it would create per shell session protocol. I'll just display it. Come on. Although you might see what you shouldn't see, people. But okay. Let me start Bash. And since that was, I believe, shortcut, grab Bash history archives, I said something about FSL and bat, right? Bat, maybe it was nifty image. Let's see. Didn't find anything. Here we go. So this comes from the history when I was doing apparently my PhD in 2009. And all of that is stored, I believe, in var bash history. Archives, yes, and there is one archive from 2017 where for each session it created kind of this fragment where it stored them. And whatever the command I ran, gbha, it was grab bash history archive, so it just does grep. So it's nothing sophisticated. It goes through this file and just finds the lines which match. But each session is identified within this setup. Okay? How do we quit the EVM? Here we go. Okay. Yeah? Good question. Not yet. Let's put it this way. Huh? Repeat the question. So can you search for commands ran within specific directory? Not in this setup, but that's a good question, and somebody might want to set up so you keep bash history within your directory, right, within some study, so you pertain only commands kind of relevant. So I said no, but later on you'll discover about such command as Datalab run, which allows you to store all those commands information within your version control system, which becomes even more powerful because then you share it with somebody and somebody could discover exactly what you ran. Okay? Let's continue, otherwise we'll never go through the basics. Okay, next one, scripting. Here we will not go through details, but raise hands please if you have created any shell script ever, if you do scripting. Here we go. That's great. So everybody knows what scripting is good for, right? So you automate your steps. Whatever you've done, let's say in this shell history, I could cut and paste those commands from the history, put it in the script, repeat it, and it runs again, right? But let's see now who knows about such settings. So by default, Bash wouldn't stop executing of the script even if it encounters some problem. So let's say you do your brain extraction and then you do your analysis. If you just put these two commands in your Bash script and first one fails, it will just continue. It didn't redo your brain extraction because it failed, but then it continued with analysis. You've got your analysis results. You didn't even realize, right, that it was done on incorrect result from BET. How do you prevent it? So if you put this set-e, it will fail if previous command fails. If some command fails, script exits with failure instead of continuing and plowing through some problems. Okay? And another one is, and then you could, if you know that the command probably might fail, you could say run this command or, echo something, let's say, oh, it failed, but it's okay, right? This way you explicitly state assumptions that it's okay for this to fail, I could go on. But in general, I would recommend I put always set-e into my script so I have a guarantee that something fails, they fail right away, so I don't plow through the errors. And another setting, which is important, is set-u. So this one says, if there is a variable which is not defined, then also fail. Why is that important? And this one kind of gives you examples. Let's say your script does something like use some prefix and they remove this command with sudo. Imagine now if prefix is not defined. You're just removing everything from your hard drive, right? You probably want to fail if something like that happens and prefix is not pointing to your directory somewhere where you think. So the set-e, set-u are really important, and I recommend in every script you write, you just put it in the beginning. So let's just do a quick demo for that. Let me get back to this. I had this Python thingy, Python. Let's say echo running Python now, right? And I will not do any changes and exiting. So if I do now run Python with something what Python doesn't understand, incorrect flag, right? Oh, Jesus. And we also loop through it. Python calls Python itself now, so it was bad decision to call Python within Python script, right? So which Python would it run here? It will run that Python because I modified my path to do that, right? So it was somewhat stupid. I'll do just for the sake of demonstration, I'll hard code the path. So now I do this and see it enters my script, it does that echo, then it complains, exits, right? And then it runs the last command. And if I want it to fail as soon as possible, bin Python, I'll just set those set-eu. Well, EU, I don't use any variables here, but it's just safety guard. Even if I don't use, I still put it in there, okay? So now if I run it, it fails right away, right? So it doesn't run this exiting. It doesn't get to that line, okay? So just make it a good habit of placing those into your scripts. Okay, do not hard code full paths in your scripts, right? So whenever you write some program, it's not even only about scripts, but any program, you could see many people just hard code full paths to their files throughout the script, right? And then it becomes non-transportable, right? So you decide to run it on another computer, those paths are not there. So a recommendation is always create a variable where you point to some path, and then you manipulate that variable as to derive, oh, what is the next place? So use relative paths or point with variable to a single location, okay? So this is kind of really basic recommendations, but I hope that through this session, whatever it was, half an hour, you've learned something new. Who learned something new? Come on. Everybody, that's what I want to see. Okay, good. So you could use history more efficient. You could make your scripts more robust, right? So your results become more reproducible in a sense, right? And what else have we learned? How to exit Vim. Here we go. So we know that now. Dave, you had a question? Oh, okay. So next topic will be more exciting, hopefully. But again, it will be basic, and everybody said that they know everything. So, but we'll go through it. Nevertheless, we're a little bit behind from original schedule. We'll talk about everything you need to know within 20 minutes, right? So Git, who knows about Debian or NeuroDebian? Who knows about Linux in general? Yeah, you've used already now Shell, right? This virtual machine is Ubuntu operating system, and Ubuntu is derived from Debian. So they took Debian, put different colors, added a little bit of other flavor into it, and called it Ubuntu. But underneath it's Debian. It's all confusing maybe, right? So, and Debian is one of the oldest and only community-driven Linux distributions. So it exists since 90s. And then we'll talk briefly about Git. So who knows what Git is? Okay, you know what it is. Okay, so what is Git? Somebody be brave, be bold. The answer was version control system, which is not incorrect. But we'll discover what it is a little bit more. Actually, let's discover it right away. How do we discover information about command on Linux? We've learned just in previous session. Come on. Yes? And now come to the surprise. What is Git? Here we go. Nothing about versioning. All right? So this whole section, and that's why we've put it together, it will not be about really specifics of how Git could be indeed used as, to some degree, version control system. It's about content management, which we use for our doing research, right? And management, it means how do we get stuff? How do we get stuff in reproducible manner that we know that we've got this specific version of things, right? And we'll cover briefly NeuroDebian, Git, Gitanix. Who has heard about Gitanix? Okay, one person. Who has heard about Datalab? 2 people? 3 people. Okay, good. Okay, so more people know about Datalab than Gitanix. That's great. Datalab is built on top of Git and Gitanix, so we've managed to hide it well that there is something else underneath. And what is all those about? They allow us to get stuff, right? The content which we need on our systems and manage it. That's all of those distributions and version control systems, they allow us to do that. And for more thorough coverage, we advise you to go again through our more detailed lessons, which are available from Repronium website, and they look kind of similar, right? But they go through more details, and you could see that we need more hours to kind of cover it, but we'll go through the basics here. So NeuroDebian, I already praised Debian, that it's oldest Linux distribution, which provides access, unified access, to thousands of software packages. So you could treat it as your, who has smartphone these days? Everybody, right? Even Kyle got one recently. Yeah. So on smartphone, you know, App Store, right? So you go click, 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 give me this app, right? So it's as easy with Debian systems or software distributions to install complex software, right? So, and NeuroDebian, we were students doing neuroimaging studies, and we didn't have that luxury. So we had to download manually whatever tools we need. We had to build them, right? We had to make sure that they work on this system. And we had to repeat it across all the hardware boxes which we had, right? Which was a tedious job. And then we decided it would be better if only one person did it, right? Instead of 10, and only once. And then we would benefit from doing this kind of sharing responsibility. And that's what Debian is about, or any software distribution you might hear about. Let's say Linux distributions, Conda distribution. Who has heard about Conda? Here we go. So Conda, initially for Python, but it provides other tools. It's where some people, maintainers, they package software and make it really convenient to be installable on your systems, okay? And in our case, we started to work with neuroimaging software because we used it, we packaged it, and that's how we called our project, which is called NeuroDebian. So what we do, we package software, integrate it, make sure that it works, upload it quite often into Debian itself, majority of the time, but also provide builds of that software for even older releases of Debian, which wouldn't be able to kind of take it and upload, because usually when Debian releases, that's it. You cannot add new stuff into it. So NeuroDebian is a project and also a repository. And here we are getting already kind of into getting a little bit more advanced. So for all the commands which we have in this tutorial, I've created a spreadsheet. So from top of this page, in introduction, I've hidden it well, right? So distributions Google spreadsheet. I would recommend you to open it, and that will be your cheat sheet for many things, I hope. And if you see that it's missing something, I would advise you to add a comment there and contribute. I don't remember if I shared it with editing or just commenting capabilities. You tell me. And whenever it opens, does it open for you guys? See, for me it takes a while. It should open, I hope. For whom it worked? Worked? Good. Okay, so it's on just me, and it's probably this Firefox browser. I'll open it in Chromium. It should be better, I think. So on this computational basis, in second topic, NeuroDebian, Git, Gitanix, Datalab, in introduction, second paragraph, I believe, this distribution Google spreadsheet. Later I'll make it more visible, so not hidden like that. Okay? And what we've tried to show in this page is a summary of concepts and commands which are somewhat similar across all of those Debian distribution, Conda distribution, right? We want to install stuff, maybe of some specific version. We want to discover which version of stuff, either it's software, either it's data, is installed, right? And this spreadsheet provides that information. And you could use it as a cheat sheet while going through example tasks here. So let's say first one exercise, check NeuroDebian. And it says, check if NeuroDebian is enabled in your virtual machine Ubuntu installation. What does it mean? Kind of a little bit cryptic, right? And let me just show what was the intention of this spreadsheet, that what are those distributions? They're collections of components, right? And they all have different things they provide, right? So in, let's say, Debian, component is a package, right, which usually provides software, right? So Debian was created to provide you content for software, so you could use new software tools, right? In Conda, Conda is usually used also to provide you software tools, usually in Python, right? And let's say in Git, it wasn't created to provide you software, it was created to provide you code and scripts and text, right? And then you could do version control with it. But Git is what? We've learned today. Stupid content tracker, right? So it provides you content, right? It knows information about where to get stuff, right? And specific versions, and typically it's used for code, scripts, and text. And then there are such tools as Gitanix and Datalab, which were geared toward data and code, not software, because they're based on Git, but they provide you also some additional features, how to manage data, okay? And below, you could find that there are those commands which you could use to either update information about components on the system or use them to provide you information about, let's say, where stuff comes from. So in this exercise, let's say we are interested in displaying information about available sources of content. So in Debian, they all come from apt repositories. That's what this spreadsheet would say here, right? So distribution mechanism to provide a collection, it's apt repository. And in this exercise, we could use this apt policy command. See where it was, apt policy, display information about sources of content. And we run it, and it tells us where it gets stuff. Once again, reproducibility quite often to figure out where I get stuff, what version I've got of stuff, right? And this is one of the commands which tells you that, oh, I'm getting stuff from somewhere in Ubuntu, right? Securityubuntu.com, oh, and here is NeuroDebian, right? So it lists all the sources, and apparently we have NeuroDebian enabled. So I could pipe this and type grep neuro, and it gives me hints, right? So here we go. The answer to the exercise was just use apt policy command and grep for neuro to see if there is, or NeuroDebian in particular, to see if I have any hits, okay? It's like rapid jump into the weeds, right, from Bash, huh? Okay, let me get back to my notes, which I had. Computational basis. Here we go. So check if NeuroDebian is enabled, solution apt policy, grep, ignore casing, NeuroDebian, that would provide. Okay, so who knows about sudo? Majority of people, right? Because we all wanted to be gods, right? So in these Linux environments which we have, to install any new software system-wide or do any changes system-wide, we need to become super user, right? And that's why this command sudo is called sudo, because it's super user to do it all. Actually, let's check man page for sudo. Sudo execute a command as another user, but by default it executes it as root. And what is great about these virtual machines, which provide you the full environment, is that you could play with them. Even if you screw it up, what you could do, you just could delete and give me the new one from scratch, right? It's like reproducibility also in a nutshell, right? You could take the full environment and share it with somebody, and they have exactly the same, right? And they could play with it and reincarnate it, okay? So in the next exercises, let's say, we want to install components, we want to search for them, right? And again, on the example of Debian, this is the spreadsheet, right? How do you find new components, right? We use, let's say, apt search command, and then we give it some term. So the first exercise here is search and install. So goal is to search and install applications to visualize neuroimaging data. Don't sneak preview, just try to do it yourself. Okay. 1 minute. This one is easy, right? We have cheat sheet. We have cheat sheet which says apt search. 3 minutes. For you, 3 minutes. For the rest is 1 minute. Okay, keep going. Apt search, and then some terms to find viewer for neuroimaging. Just be inventive. Who found any? What was your search term? So you just search for what you know this tool, right? So MRI cron. MRI, here we go. Here we go. MRI will be a little bit too loose, right? Because then it's like all kinds of internet radio station and Ruby thread. So again, we talked about data before and all the terms, and this is example where we look for a free text. It provides us hints for stuff, right? It's not exactly the match unless we know exactly the name. Let's say if I knew MRI cron, if I looked for MRI cron, I could find it. 10 minutes for you to do search? Oh, what is left for me? 10 minutes. Okay, good. So again, with those tools and distributions, they all have some capability for searching for stuff. It's like in your Play Store, you search for something, you find, you install. The same here. And here I could look for specific tool, MRI cron, if I know how to it's called, or I could give different queries, right? So as an example here, if I enter medical viewer, I get some results, right? And it gives me names of the packages which I could install to get the viewer. And because we will use them later on, let's get few installed. So how easy to install? We use apt install, and then let's say, I don't know if this one works, but FSL view. What is your favorite? MRI cron, right? There we go. And this is the sudo part, right? So by default, I cannot modify anything system-wide. So I need to prepend command. Again, I brought it from the history. Okay, I put up. This is my history. Control A, sudo. This way, I didn't have to retype it again. Type sudo. And what happens now, all those distributions, Debian, Conda, Datalab, they allow us to search for stuff and install stuff. Some kind of stuff. Software, data, code, text, right? And that's what I'm doing here. I was too ambitious. I will not do a full installation. I'll install something compact, maybe FSL view. But the point remains. So with distributions, why not? Yes. With distributions, we could search, we could find what we need, we could install it. Okay? But we also need to figure out how to install specific version. Okay? Install your choice. That's what we are doing now. Multiple available versions. So how could you do that exercise? Just give me the answer. You have the spreadsheet. And we already ran that command. Who could guess? How could we figure out which versions of that toolkit are available in the system? Apt search could, but it wouldn't give me the versions. It would just, or maybe it would. Okay, let's do apt search. Maybe I was wrong. Here we go. It actually, it gives it, but not entirely. It gives that this is the version which would be installed. It's not, doesn't give me, oh, this is the versions I have available to be installed. Okay? So for that, there is another command. It's this, display what versions of the components are available. And it's, again, apt policy, which we use to just display me the sources. But if I give it the name of the tool, it gives me, oh, there are multiple versions. Let me clear and make it again. So again, we are just discovering what and where from it's coming. And we could instruct apt, in this case, to install specific version of the command. Let's say connectome workbench equal to this one, because by default it would install newer version in this case. And I could say install me, again, sudo. That's a good exercise, right? Here we go. Now I would install new version. And for those who were bored, there is a new exercise down there, how to install or find yet another version from somewhere in snapshot. See, for bored challenged. You could do it at home, because those guys will kick me out from the stage soon. Okay, any questions so far? We've learned through Debian that we could have access from the collection of components to specific components, could discover what versions are available. We could install specific version. And in general, it was painless, right? So regardless how complex the component is, most of the time, it's just apt install away. I don't need to download and compile, and then it would fail. I need to talk to somebody. I just apt install, and I have it. And this will be used in next exercises where you would prepare your own full environment like that. We prepared for you VirtualBox, right? But sometimes you want your own kind of, I want smaller, but with specific versions of software, which are coming from different distributions, okay? We will do, Dorota will show you how. Okay, so now we get to Git. So everybody loves version control by now, I hope. At least, who didn't use Git? I'll ask this way. Who didn't use Git ever? One person, two person. So Git is, again, it allows you to get stuff to your laptop and manage it. And what does it mean, manage? You could introduce your changes. Unlike here, I could just install what is provided by distribution, right? With Git, I could, from ground zero or from somewhere, I could clone the repository. Repository is just collection of files. And I could do my changes, and I could annotate them with what has happened, what did I do. So what is Git? We answered already, right? Consult man Git. And again, I'll repeat, as the Bible says. What is Git? Stupid content tracker. Here we go. Yeah? And tell Git about yourself. That will be our first exercise. In this virtual machine, nothing is configured for using Git. We have Git command. Which Git? It's installed system-wide user bin Git, right? But then if we create new repository, let's say I'll create repo, and I'll create some file, 123 into 123, and I do git add 123. Oh, Jesus, I didn't do git init, right? So for majority of people who know how to use Git, that's the first step if you start working with a new repository. You create directory, you initialize it, and then if you have a file, you add it into Git. And then when I do commit, it says, oh, you need to set up your name, right? So that's the first step to configure Git to be used on the system. So let's everybody do that. You don't have to provide your real names or real email addresses. But in the real life case, I would recommend you to do that. Because then later on people could, they know whom to bug or whom to acknowledge, about work they've done. And that's what we rely on our projects. Let's say for all the source code which we commit, we use our real names. And then whenever our project gets released on Zenodo, all contributors, they get acknowledged because their name's part of the Git history of those changes. So I would recommend to put real email. It might be the one which is spam resistant. So I do user email and then user name. And there we go. Now my Git is ready, and what happened actually, it just created Git config file in your home directory of the home directory, which has the settings recorded. So that's where Git stores all the configuration settings, global one. This is about global settings. We will not go in details because again, for Git to cover Git at all, or in full, it would take a few hours. We didn't have that. But we've done this exercise. Git command help, we've done that before as well. So for every command in there, let's say git config, you could type git config help, which gives you specific help for that command, okay? And we know how to quit, it's Q. Question, what is the version of the content you've got? Oh, hold on, we need to install exercise. So we have this whole repository, and that's what I was asking, and let's install it. And for those who don't know how to use Git, there is this page, right? And we could look up how to install stuff. Let's do exercise. And whenever you're done, put yellow tab. If something doesn't work, let me know.
Let's do the exercise.
Maybe it's wrong. See, there was a typo. Gee. Yeah, so it needs to be OHBM 2018 training. I'm sorry. Thank you. See, again, whenever sources are stated incorrectly, try to reproduce it, huh? See? That's the problem. Okay, so this is how it does. Right? We do git clone and then URL. We get that component locally. Now, who knows how to answer the question, what is the version of the content you've got? Because this version control system, right, how people call Git, it allows you to have multiple versions kind of contained within the same repository. Okay, give me the answer. Git clone. Log, git log, right? So that's one way. Git log gives you the log for all the changes in your repository which led to this point. So I'll clone this. Almost there, almost there. Here we go. So now if I go to that directory and I could run git log, which gives me the log for all the changes. And you could see that there is no word version, right? There is only commit and then some non-decipherable thing, right? And then we have this history of things, right? But if you want something comparable, usually there is also tags, right? So you could put a tag for specific versions. And in our case, we have only one tag. So the command tag gives you which versions are available. And whenever you clone something, you could ask, describe me the state here. And git describe will then take the tag and it will say, it's from that tag 8 additional commits and current content, so whatever you see in git log or git show, this long string, this is the beginning of it. So, head. See, it's the same. And this is how content identified in Git. So content in Git identified by checksum. Who knows what checksum is? Who doesn't know what checksum is? Okay, checksum is some concise summary of data which changes completely if you change anything in that data. So it could be, let's say, for your file, you could sum up all the numbers in the file. It could be a checksum, right? But then it will not be reliable because you could change one number up, one down, sum doesn't change. It's kind of boring. That's why smart people created those checksums like MD5 sum or SHA-1 sum, which identify the content so that if anything changes, then checksum changes completely. And what you see here is just SHA-1 sum of the content. And what next section here states is actually Git philosophy in 2 minutes, which is, again, Git is what? Stupid content tracker. All the content is identified by the checksum. And then content is stored within this .git objects. So in every Git repository, which we have now, that's where the content is stored by Git. So we could go through different versions, and that's where it resides. And as you know, Git is, and then there is branches and tags. So we have content, and then we have branches and tags, which just pointers to the content. Again, we cannot go through all details of Git, but if you know Git a little bit, just think about it in these terms. We have content, which is stored among all the clones. Then we have branches and tags, which point to specific versions of the content. Okay, let me speed up a little bit more. Time travel we'll skip for now, but that's what Git is great for, because we have log of all the changes. We could go to specific version of those changes, and we could inspect them. Okay, what does Git Annex allow us to do? So Git Annex is a tool built on top of Git, which takes big files, and it doesn't store them in Git objects. It places them aside. It places them into Git Annex objects, so they never get committed into Git. So imagine you have 1 gigabyte file. If you commit it to Git, it will be placed into Git objects. And then every clone of that repository will have that 1 gigabyte file, even if they don't want to use it. That's the beauty of Git, right? It's distributed. So it distributes this 1 gigabyte across all of the clones. So Git Annex allows not to put those files directly into Git. We will not do exercise directly here, but we will do it with Datalab just slightly later. And then what Git Annex does, it commits this, it replaces the file with symbolic link to that content file, which it commits to Git. So into Git, it commits only symbolic link. Here I'm just making a jump from Git philosophy, which commit everything into Git objects and distribute everywhere. Git Annex commits only symbolic link into Git and then shares it with the world, while keeps information where that file could be obtained from. And we'll see example just now. Now we go to Datalab. As Neuroimaging was born to provide software, Datalab was created to provide datasets through Git and Git Annex from many portals through unified interface. So if we go now, let's say, to datalabs.dataset.org, you could see, I'm offline or what? What? Oh, Jesus, so many typos, huh? Datasets.datalab.org. Datasets.datalab.org, whenever it loads, it shows that we collected already around 12 terabytes of datasets, which we don't provide, but Git Annex allows to access from wherever they're available from. And actually, we'll do quickly one exercise, which will be install a dataset. And in this case, we'll install this particular dataset, which should have been loaded. For some reason, my internet now, or did they bring down the server? I don't know. For whom does it work? Who could go to datasets.datalab.org? So it's only me. Okay, great. Let's do the exercise, and then we'll see how Git is different. Oh, Git Annex is different. And whenever you went to that web page at the top, it should give you the command, right? Datalab install, it's just a shortcut. You could provide the full URL here into install, but let's do this. Datalab is not available in our bash, right? I'll disclose, which will be used in the next sessions, that we use Conda environments for our subsections of the training course. And in Conda, again, we have this spreadsheet. If you look into Conda, it could tell you, maybe at the bottom, how to see those environments. And there is a command conda env list. Let me go here, conda environment list. And it says that there is different environments, and we need environment for section 2. So we'll do source activate, that's conda's command. And which section? Section 2. You could see that my bash prompt changed. It says section 2, and if I do conda env list, it will put a star here. So please do that in your terminals, and it will be useful for next ones to know as well, right?
Okay. I think we should check that everyone is still on board. Who is fully on board, is doing it, is not lost. Can you raise your hands if you're okay? Okay, so a couple of people not raising hands. So just making sure that we are okay. So if you're a bit lost, if there's something that you haven't understood, please put a little red or pink sticker, and we'll come to you and try to get you back on track.
Okay, what we've done with this source activate, do you know what we've done? We picked the environment. So now we have new commands available, like Datalab. And how now it finds it? Which environment variable instructs where to find stuff? Because now our path points to additional directory. So whatever that source activate did, it modified our path to point to additional places to find software. Okay? So now we have Datalab. If you don't have Datalab, you need to type source activate section 2. Okay? And now we could install. I'm bringing that command back. What? I should sit there? No, there is a question. Sorry.
I was forced to make this question public. So are you going to explain the environment, how environments work in Conda and the source activate and all that stuff?
We could spend some minutes. That's why I was trying to cheat and provide this spreadsheet. So at the bottom of it, when we talk about environments, right, the main commands are here at the bottom. So conda env list lists your available environments, activate activates specific one, source activate, and source deactivate deactivates it. Okay, that's the main commands you would need to know. How it works, it's a stretched question. How they come about. Why it's useful? That's a great question. Yes, environments are great. Let's say this virtual machine. It's an environment. So we decided to teach a course and provide you with unified environment on all your computers. We provided virtual machine. But virtual machine is heavy, right? So you had to download 4 gigabytes, right? Install it, and then it runs on top of your operating system. Conda environments, they're much smaller, right? They allow you to install only the tools you want from Conda and have this tiny environment for running, and you could switch between them really quickly. Okay, so it allows you to experiment, to bundle into specific versions within that environment. I would say that's why they're useful. Yes?
Back in my lab, would there be any reason for me to install multiple environments, or typically I just install an environment to use and then go about my...
If you want, there are multiple reasons why you want to use environments. One of them, let's say you want to restrict versions to specific versions of software for a study, right? You have an environment, then you have an environment you maintain through the course of your study. So if new tools appear, you don't install new versions, so you have consistent versions throughout your experiment. If you start installing new things and then analyze some data with old tool, some data with new tool, right? You'll get maybe differences simply because different versions of software. Imagine you did longitudinal study, then all earlier subjects were analyzed with one free surfer and other ones with another free surfer, right? So ideally, for the study, you want an environment which you maintain through the course of it. If you have to change it, ideally, you need to recompute all previous results. And that's what we'll do, hopefully, if we have enough time, right, in the upcoming course, in upcoming lessons.
So yeah, we're going to change a bit the schedule. If you could finish, not in like in some brief time.
Yeah, I am.
And then we're going to go for lunch and then come back early. So that's just to make sure that everybody.
Okay. So I'll finish up with information that Datalab provides you distribution for datasets, but also a tool which sits on top of Git and Gitanix to manage your datasets and help you to record the actions which you've done. Like I promised, like you could have your history of commands which you executed, and that was our exercise here. You'll record it, it will record it within your Git history, so later on you could either discover what you have done or simply rerun that execution and see if you could reproduce the same results. Let's say you've changed your environment, you reran all the results, you see, oh, they're the same, I'm cool, right? You've changed your environment, you rerun it, and you see, oh, these results changed. And that's where Git and Gitanix help you because they keep all the data, all the scripts in the version control system, so you have access to all the stages of your research which you've done before. And did it install it? No. What? See, my connection. For whom did it finish installing? Is it just me or for... No? So for everybody it's kind of hanging there, huh? It's slow. It's too popular website today, huh? What we would get at the end, after this installation, it will be just a Git-Annex repository. And let me just show you just one example how that is different from, so I'll do source activate section 2, and I'll create a new data set. So Datalab has now create helper, which test repo, I'll call it. What it does, it pretty much creates Git and Gitanix repository. So it's Git. It's regular Git repository, which has .git, but also it got some additional superpowers, let's call it this way. And now I'll create a new file, 123, and I want to demonstrate how Gitanix, imagine this 123 is a huge file. By default, everything will go into Gitanix. And I'll say, add this file, add in important data, 123. What will happen now? We have Git history, Git log, we recorded, right? So we added important data, but the file itself is not just a file, it's a symbolic link, right? Where it moved the content into Git-Annex objects, not into Git objects. That's the main difference from Git into Git-Annex. So it allows to keep big files. In this case, it was tiny file, but regardless what is the size, Git-Annex then would allow to store information about the files, and they are identified by the checksum. So if anything changes within that file, checksum would change, then new symbolic link would need to be committed into Git. Okay? Yes?
If I'm worried about, so if I'm worried about like HIPAA problems or moving my files elsewhere, none of this stuff really pushes the files anywhere but on my local computer. It's just keeping track of versions of things on my local computer.
Yes. So it doesn't publish anything by default. You could push this Git repository to GitHub, and it just will not have those files because they're somewhere on your hard drive only, and that's what Git-Annex manages for you. There is a command where is. Git-Annex where is, it just says that it's available on this box only. If it was available on the web, it would say, oh, it's available from this URL as well. So Git-Annex allows you just to track where stuff is available from. Yes, Dave?
Yeah, so I could create my own data set locally. I could run my analysis locally. I could do all this checking in and checking out locally and keep my own version. It's all done locally.
That's right. That's right. And for me, installing finished, and just one little example before I conclude, I'll go to real data, right? So here we have a Git repository with lots of history, and it comes from OpenFMRI website, but here it's just Git repository. And data files here were placed under Gitanix control. See, and I cloned it. Although it took a while, it should have taken just a minute. It wouldn't download any of the big data files. It would just download the history and information where data files are available from. And now I could say, Datalab, get me this file. And what happens, then Datalab goes wherever it needs to go and downloads that file from wherever it could. So this way you could manage your data without always dragging the full content, but only having the files. Well, usually it goes faster than 0 bytes per second, right? And distribute your data across your computing infrastructure. So it becomes really kind of nice without losing information where the data files are available from. And I guess on this we'll conclude, but we'll get back into Datalab after the
After the break.
After a break, yeah.
Thank you. Big round of applause.
Woohoo!